India's geography and climate make it prone to a host of natural disasters. Floods, droughts, cyclones, earthquakes and landslides are recurrent phenomena. These disasters kill thousands of citizens and destroy millions of rupees worth of property and assets. It is of vital importance that we reduce and manage disaster risk. Indigenous science and technology can play a big role in reducing risk, in helping us handle each disaster with internal resources, in making us more self-sufficient. Over the years, India has seen disasters of enormous magnitude. The super cyclone of 1999 that hit Odisha with wind speeds of 300 kilometers an hour for over 30 hours, killing close to 15,000. The earthquake in Bhuj in 2001 that injured over 1.5 lakhs and made nearly 400,000 homeless. The tsunami of 2004 that killed over 2 lakh Indians and caused immense economic damage. The Bihar flood of 2007 that took thousands of lives and damaged livestock and property. The flash floods in Uttarakhand in 2013, which affected more than 9 million people and killed close to 5,000. Disasters cause enormous damage to life, property and the environment. And so, having the mechanisms in place to cope with any disaster are critical. 80% of disasters are associated with weather and climate. To manage this, our most valuable tool is weather prediction. A common disaster in the Indian subcontinent is the tropical cyclone. With a coastline of over 7,500 kilometers, India is exposed to nearly 10% of the world's tropical cyclones. Every year, there are 5 to 6 big cyclone formations along the Bay of Bengal, of which 2 are likely to worsen. These often hit states along the eastern coast of India like Andhra Pradesh, Odisha, Tamil Nadu and West Bengal with devastating consequences. Compared to earlier cyclones, today the impact has been highly reduced because of weather prediction mechanisms. The hub of all our weather prediction mechanisms lie in the prestigious Indian Meteorological Department, IMD. From a modest beginning in 1875, IMD has progressively expanded its infrastructure for meteorological observations, communications, forecasting and weather services. India was the first developing country to have its own geostationary satellite, INSAT, for continuous weather monitoring of this part of the globe and particularly for cyclone warning. Today, the IMD has impressive systems geared towards the monitoring and prediction of tropical cyclones over Bay of Bengal and the Arabian Sea. The basic observations of these forecasts come from a variety of sources that include automatic weather stations, automatic rain gauge station ships, ocean buoys, satellite data, Doppler weather radars and high wind speed recorders installed along the Indian coastal belt. This produces detailed information about the cyclone, including its genesis, location in terms of latitude and longitude, movement, intensity and time of landfall.
In recent years, IMD has come up with impact-based forecast and risk-based warning. So we provide the information not only whether the weather will be or what the weather will be tomorrow, but also what the weather will do tomorrow.
The critical part of these systems is to make sure that the warning comes early enough to move people to safety and take the necessary steps on the ground.
Early warning consists of various components. In atmospheric science, we say it is an initial value problem. It means if you can detect weather correctly, you can also predict weather correctly. So therefore, worldwide, people try always to improve the observational system so that no weather system goes undetected. Similarly, people try to develop the numerical weather prediction models so that no weather system goes unpredicted.
There are numerous steps involved in getting together all the technology and expertise for this kind of early detection. Specialized satellites like INSAT 3D, INSAT 3DR and SCATSAT-1 are used to monitor the Earth's surface and carry out oceanic observations. Scatterometers are devices present in these satellites that read the reflected signals from the oceanic surfaces in terms of wind speed and direction. The data collected by the scatterometer is run through various numerical weather prediction models for analysis to measure and determine a cyclonic storm in advance. If a possible cyclone is detected, the data is run through the Ministry of Earth Sciences and Information, where overall information of the cyclone is further analyzed in advance. Once the information is extracted through this numerical process, early warning is issued to various stakeholders and departments for required action. This would include the media, general public, and disaster management agencies. With the latest technology, the genesis of a cyclone can be found at least 5 days in advance. This gives time for the local authorities and disaster management agencies to prepare for impending disaster and minimize loss of life and property.
And while we issue the early warning, we inform about the expected impact to the structure, expected impact to the agriculture, industry, human population, houses, telecommunications, power sectors and all. So therefore, this information, when it is transmitted from India Meteorology Department to the general public, media, disaster managers at state and central level, that information acts as the first step to initiate action.
The bulletin issued by the IMD is an end-to-end solution. It contains the info about everything: current status, forecast, expected weather, impact and damages. It also mentions the actions that must be taken by the general public and disaster management. Each sector can work in systems based on this information. This is very useful for vulnerable communities like the fishermen and farmers along the coast. With the impact-based early warning system, specific warnings will be issued and it aims to reduce the loss of human life and loss of property.
There has been a drastic reduction in the number of loss of lives. When you had 10,000 loss of life in 99 super cyclone Odisha, we have got only around 21 deaths due to the cyclone Phili in 2013. We got 64 deaths only due to the cyclone Phani in 2019. We got 78 deaths only due to the cyclone Amphan in 2020. So this remarkable achievement in reducing the loss of lives has been possible because of the active role played by the disaster managers utilizing the improved early warning provided by India Meteorological Department.
There has been a big change in how prepared we are when disasters like cyclones hit. Science and technology has a critical role to play in building disaster resilience and contributing to our journey towards self-reliance.
India Meteorological Department and Ministry of Earth Sciences have its own high power computing system. It is running its own numerical weather prediction models. It has got its own observational systems, and also it has got its information and communication technology and early warning dissemination systems. So therefore, our entire early warning system is completely, you can say, or mostly self-reliant or Atmanirbhat.
The IMD not just protects India, but issues advisories to over 13 countries in the region. This provides an umbrella of protection over the region, saving both lives and property. Next up, extreme events in the Himalayan ranges have become more common. Again, Access to information on weather patterns can help manage disasters effectively. Keep watching to explore a unique state-of-the-art radar system in Uttarakhand. India Science Channel was launched in the year 2019 by the Department of Science and Technology, Government of India. The internet-based dedicated science web channel is being implemented and managed by Vigyan Prasar, committed towards science communication. The channel features science documentaries, discussions on current topics, interviews, and different programs covering the entire landscape of science and technology to make science popular among the masses.
India Science is a flagship project of Vigyan Prasar. And over a year and a half, we have produced more than 1,200 videos of different sizes, lengths, and are from different genre and for different domains for the people of the country. We've taken, we have spoken, we've gotten, we've dived deep into the realms of different domains of science and technology, and we have gotten news, stories, films, videos, in almost every format that you can think of. OTT, for that matter, is a great platform that helps anybody to look for any news, any item, any video, any documentary at any point in time. All you need to do is to subscribe a channel for it.
One can also download India Science mobile app from Google Play Store or Apple Store to view this channel. The great Himalayan ranges, majestic in their beauty, but home to an increasing number of disasters. Earthquakes, avalanches and floods. This trend in natural disasters seems to be going up. Factors contributing to this include climate change, thoughtless development in the region, and a growing population. It is clear that massive efforts have to be mounted together with sound scientific strategies for mitigation if we are to deal better with disasters. The Aryabhatta Research Institute of Observational Sciences, ARIES, located in Nainital in the foothills of Himalayas, has been studying the changing weather patterns in the Himalayan belt by closely monitoring the atmospheric conditions.
There was a huge cloud burst a few years back in Himalayas. So we need to have a better understanding about why such a huge sudden formation of the clouds, and if such formation of the clouds and then the burst, then what are the kind of disasters it can lead to. So that demands a basic understanding of the cloud formation itself. So that way our regular observations during the rains, during the clouds, during the thunderstorms gives us very, very valuable input.
To monitor all the conditions effectively, ARIES has developed an advanced radar system known as ST radar or Stratosphere-Troposphere radar. Radars have been proven to be excellent tools in measure various atmospheric parameters used for basic atmospheric research, weather forecasting and disaster management. Let us quickly understand what radar is before exploring the working of this system. Radar is an acronym for radio detection and ranging. In its simplest form, it consists of a transmitted radio signal aimed by an antenna in a particular direction and a receiver that detects the echoes of any objects in the path of the signal. The intensity of the received signal will be affected by weather conditions like wind and precipitation. This way, the radar has the capacity to read the wind movement in the atmosphere. Let's explore the radar at ARIES in a bit more detail. It is a pulse Doppler radar, which means it measures the frequency, speed and direction of a moving object in the atmosphere, in this case the wind. The ST radar installed on the rooftop of Aries has 588 antennas arranged in equilateral triangular grid, which means that whichever way one looks, the antennas are arranged in a straight line. This ensures that the radio frequency energy or RF energy is radiated properly. Each antenna has a director, folded dipole and a reflector, which combines to ensure that the beam is directed to the desired direction. All these 588 transmit-receive modules, also known as TRMs, are hung from the rooftop. This is designed in such a way that the entire radar system is accommodated in a single building, which saves space and cost in this difficult hilly terrain. The floor space can be used for the maintenance of the radar system. This is the first time in India and most probably in the world that such design has been successfully installed.
The Nainital is very complex terrain. You can see it is difficult to find this such large space of 30 meter by 30 meter. So then again it is suggested to set up this radar over the building. So that is also totally indigenous, like globally people put the radar on the ground. So this again for the first time we put this such radar on the top of the building, like on the rooftop we have the antenna, and then middle floor we have the TR module hanging, and then ground floor we have the radar controller. So with this entire uniqueness, I will say it is totally independently made within the Indian system.
All the TRMs radiate and receive the radio frequency at the same time. So it goes to the transit mode at the same time and comes back to the receive mode at the same time. The operation is controlled by the Timing Signal Generation Board (TSG) placed in each TRM. The feed from the TRM goes to the radar control room placed on the ground floor of the building. Here there are two softwares, the radar controller software and the signal processing software. The radar control software configures the radar operation of all the TRMs. The digital signal processing unit receives the signal, which gives information about wind speed and direction. The information is again read scientifically to determine the behavior of the atmosphere and the wind pattern. The radar covers a horizontal distance of 50 kilometers and a vertical distance of nearly 20 kilometers, which helps in determining the weather change pattern in the middle or lower troposphere.
The radar can operate for 24 hours. So when we are depending on our interest, we are operating 24 hours. So it can give the early warning system, like when we see this highly turbulent atmosphere is there. So we can also alert the people and also the government.
The ST radar operates at a frequency of 200 MHz. This ST radar gives wind information regularly for 24 hours, 365 days in any weather condition. Aries feeds their data to other nodal organizations like IMD and ISRO, so they can manage weather and disaster predictions for this region.
The beauty of this project, I will say this is totally indigenous project set up here in collaboration with ISRO, and this radar was basically supplied or installed and developed by the ECIL. And operation and maintenance of this radar is also being done by the totally Aries technical team, technical assistant. So I will say it is 100% Atmanirbhat.
With its unique geographical location and the state-of-the-art equipment, this laboratory has ensured that we get information in time to mitigate disasters varying from storms to air crashes in this area. Another huge risk in this region, especially with changes in the climate, are GLOFs or Glacial Lake Outburst floods. This happens when the water in a glacial lake bursts out. And it can cause irreparable damages. Do we have any way of predicting this in time to mitigate the damage? Keep watching to find out more.
India Science Channel was launched in the year 2019 by the Department of Science and Technology, Government of India. The internet-based dedicated science web channel is being implemented and managed by Vigyan Prasar, committed towards science communication. The channel features science documentaries, discussions on current topics, interviews and different programs covering the entire landscape of science and technology to make science popular among the masses.
India Science is a flagship project of Vigyan Prasar. And over a year and a half, we have produced more than 1,200 videos of different sizes, lengths, and are from different genre and for different domains for the people of the country. We've taken, we have spoken, we've gotten, we've dived deep into the realms of different domains of science and technology, and we have gotten news, stories, films, videos, in almost every format that you can think of. OTT, for that matter, is a great platform that helps anybody to look for any news, any item, any video, any documentary at any point in time. All you need to do is to subscribe a channel for it.
One can also download India Science mobile app from Google Play Store or Apple Store to view this channel.
Climate change has made some disasters more common. It has changed the precipitation and temperature patterns all over the world. With increasing global surface temperatures, the possibility of more droughts and increased intensity of storms will likely occur. As more water vapor is evaporated into the atmosphere, it becomes fuel for more powerful storms to develop. This increase in the temperature due to global warming has led to the phenomenon of glacial melting and flooding. Once the glacier melts, there can be a sudden release of water, which results in a glacial lake outburst flood, or GLOF. An event like this unleashes huge amounts of water. These glacial floods have a huge potential for damage. They can wreak havoc on villages, agricultural areas, and infrastructure. The Himalayas have about 9,600 glaciers, with the largest reserves of water in the form of ice and snow outside the polar regions. Here, the eastern Himalayan region seems more prone to GLOF events. The state of Sikkim alone shows the presence of 320 glacial lakes. Sikkim also falls in Zone 4 of the Indian seismic chart, and earthquakes here are likely to trigger GLOFs. And so, institutes like the Pune-based Center for Development of Advanced Computing, CDAC, have focused on using technology to track GLOF events in the state of Sikkim.
Since last 3 decades, CDAC has been working on indigenous solutions of national importance, and GLOF early warning system is one such example which is first of its kind in the country. The entire system is developed in-house, and even the water level sensor, which senses the changes in the water level in the glacial lake, were indigenously developed by CDAC.
Let's explore the mechanism of a GLOF in more detail. As they retreat, glaciers leave behind moraines, accumulation of boulders, stones or other debris in the valley. This leads to the formation of moraine-dammed lakes. Such moraines often contain a melting ice core built from transported rock debris. Why is there an outburst? This can be triggered by several factors: ice or rock avalanches, the collapse of the moraine dams due to the melting of ice buried within, the washing out of fine material by springs flowing through the dam, piping, earthquakes or sudden inputs of water into the lake, example through heavy rains or drainage from the lakes further up glacier. These floods have already caused hundreds of fatalities across the world, destroying downstream communities and stunting the socio-ecological integrity in their wake. So teams at CDAC have been monitoring and tracking the lakes. They use satellite imagery to analyze change in these lakes. On a pilot basis, water level sensors have been deployed in a few glacial lakes in the state of Sikkim to help in the monitoring. The GLOF analysis is done with the help of three sub-tools: lake information, simulation, and the sensor information. Lake information gives basic information about the glacial lake, while the simulate module gives information regarding the GLOF simulation progress and the outputs of the simulation. The model is capable of presenting flood simulation, inundation information, and flood arrival time in the event of a GLOF. The sensor information module gives basic information about the sensors deployed at the glacial lakes for monitoring water levels. Each sensor has a sensor ID linked to the lake ID.
These solutions have been built under the National Supercomputing Mission of Ministry of Electronics and IT and DST, Government of India. And since they require huge amount of compute and storage, they will be provided by the supercomputing systems built under NSM. The country's largest and fastest 210 AI petaflop supercomputer, Param Siddhi AI, at CDAC will also be very extensively used for this purpose.
Data shows that many lakes in Sikkim have been increasing in size and volume since 1965. Their area has increased significantly, and this indicates the lakes are important from the disaster point of view. In addition, new lakes have also developed due to glacier retreat and melting. However, with this early warning system developed by CDAC, the Sikkim government and authorities can take the necessary steps to ensure that there is preparation on the ground to plan for and mitigate the effects of any disaster.
The all-weather sensors are completely made in India by CDAC. The decision support software as well as the GLOF simulation models are all based on open source models fully developed by CDAC. Even the data transmission which is taking place is through the Indian communication satellites. So therefore, it is truly and holistically a completely made in India and made for India solution.
What has emerged in any disaster management system is the importance of early warning. Weather prediction tools play a big part in this, since they help the system gear up to reduce the impact of any disaster. With the advances in science, India has the indigenous capacity to predict most disasters without relying on the outside help. With this, the mitigation and management tools can be activated to minimize harm to life and property.